Hello guys, is audio video clear? Is audio video clear? Guys, is audio video clear? Okay, so we will start our discussion. We'll start our discussion. Quickly join the class. So wait a second. Okay, so let's start now. Let's start now, class. Okay, so this is all about me. It's all about me. You can go through my profile, guys. Okay, you can go through my profile, guys. And now we have the RRB JE CBT2 on our application right now. Okay, so the application link is provided in the chat section. So you'll get the complete uh, 400 hours of the live class for the CBT2. Okay, this is the technical, involves both civil and the mechanical. Okay, so you'll get the PYQs, you will get the PYQ solutions there. You'll get what? You'll get the quiz solutions, you'll get the test series and doubt solving sessions also. Okay, so these features are available for our, okay, for our RRB JE students. Okay, right now, okay, we are having the scholarship test for 25th, 26th, and 27th December. Okay, okay, guys, the prizes for the scholarship are provided here. Okay, the prizes for the scholarship are provided here. So if we get the 1 to 5 rank, you will get 85% off on, okay, all state AEJ exam courses. Okay, okay, guys. So the scholarship will start from tomorrow and it will remain for 3 days. It will remain active for 3 days. Okay, guys. Okay, absolutely correct. Absolutely correct. Okay, okay, wait a second. Now, okay, this is a scholarship. You will get the 85% scholarship. You will get the 85% scholarship. Okay, now let us start our class. Let us start our class, guys. Okay, the first question on your screen. Mark down the answer for question number one. The question number high. Okay, question number one on your screen. Question number one on your screen. So I want the answer right now. I want the answer right now. We have a cantilever beam which has a span of 1 meter or 1. Absolutely correct. Subject to the moment P at its free end. So we are applying the moment P at the free end. The bending moment induced, okay, at its support will be. How much is the bending moment? How much is the bending moment? I want the answer, guys. So what is the answer? Okay, so answer is D. Okay, so let us make the beam, guys. Let us make the beam, cantilever beam, subjected to the moment what? Subjected to the moment M at the free end. So we are applying the moment P at the free end. So there will be the induction of the moment P. Sorry, moment P at what? At the fixed support. Okay, guys. So the answer should be D of this question. Okay. So for the cantilever, I'll write down for cantilever, everything happens at the fixed support. That is the maximum shear or maximum slope or anything. Everything for cantilever, everything happens at what? Everything happens at fixed support, guys. Okay, fixed support. Another question for you. Another question for you. Okay, guys, another question for you. I want the answer right. I want the answer, guys. Quickly, I want the answer. So what is the answer for this question now? What is the answer for this question now? Okay. So dash is the algebraic sum of moments of the forces on either side of the section of a loaded beam. Okay. Sir, please share force diagram and bending moment. Sir, please share force and bending moment diagram. For what? For what? Okay. So dash is the algebraic sum of moment of the forces on either side of the section. So that is called the bending moment. That is called the bending moment. Let us take, okay, question number one. Okay, I'll make the shear force diagram for the question number one. So guys, this was the question number one. So we are applying the moment P. Now I am making the bending moment diagram. How can I make the first? I will make the shear force diagram. Sir, there is no load acting on the beam. There is no load acting on the beam. That means, sir, the vertical reaction induced at this support, at the free support, is equal to zero. Vertical reaction is zero. That means there is no shear force. There is no shear force diagram for this question. Okay. Now let us make the moment diagram. Let us make the moment diagram. Guys, I am applying the clockwise movement here. I'm applying the clockwise movement P at the free end. Okay, there will be the anti-clockwise movement induced at the fixed support. Okay, at the fixed support. Now, sir, the bending moment diagram. Okay, on the fixed end, I am applying the what moment that is anti-clockwise. So I am making the moment M downwards. Okay, now then, sir, there is no movement till the free end, sir. At the free end, we are applying a clockwise movement. So I am going upward. This is the bending moment diagram for the cantilever. Okay, guys, this is bending moment diagram for the cantilever subjected to the moment P, subjected to the moment P at the free end. Okay, no shear force diagram, no shear force diagram because no loading. This is the bending moment diagram, guys. Okay, next question for you guys. Next question for you. Next question for you. Okay, it was the bending moment. The question, the answer was for this question, bending moment. Okay, so I'll solve the next question, guys. Next question. Okay, dash. What type of the beam is is supported only at the one end by built? Okay, by being built into the wall. Okay, what is the answer now? What is the answer, guys? What is the answer? So B is the answer. B is the answer. Okay, B is the answer. So here it is which type of the beam is supported only at one end by being built into the wall. So we have a wall here, guys. We have the wall here. So we are building a beam into the wall. Okay, it is fixed at only one end. That means this will be cantilever beam, guys. This will be cantilever beam. So this is the wall. This is the wall. This is cantilever. This is cantilever. Okay, guys. Sir, only one support, guys. Okay, that is the fixed support. That is the fixed support. Sir, there will be the generation of movement M. There will be the vertical reaction V. And there will be the horizontal reaction H. Okay, there are three unknowns. There are three unknowns. So the answer should be cantilever beam, guys. Next question, guys. Next question. Next question for you. So the question here says a beam of length L plus 2A. The beam of length L plus 2A as a support L apart, with the overhang A on each side. Okay, this is the overhang beam. Okay, guys, the beam carries a concentrated load W at the each end. So we are applying the load W at each end. The shear force between the two supports is given by. So let us make the shear force diagram. It will be clear then. It will be clear, guys. Let's make the shear force diagram. It will be clear. Okay. So quickly make the shear force diagram. Quickly make the shear force diagram, guys. Make the shear force diagram. Okay. So we have a beam given. Sir, this is the beam. The supports are at the distance of L. Okay, the supports are at the distance of L. And guys, okay, this beam has the equal overhang on both the sides. Equal overhang on both the sides. Absolutely correct. We are applying the load W at wire, guys, at the free ends. At the ends, guys, we are applying the load W. So what are the reaction is? What are the reaction is? Okay, there is the load W. There is the load W. Since the beam is symmetrical, that means the support reaction will be W. Support reaction will be W, guys. Absolutely correct. Because the summation Fx, summation Fy must be equal to 0, guys. Vertical, downward, upward forces must be equal to 0. Must be equal to 0. Okay. So it is W, it is W. Now I'm making the shear force diagram. How can I make the shear force diagram, guys? Okay, we have discussed it in the class, the shear force diagram. How can we make the shear force diagram? Okay, wait a second, guys. How can we make the shear force diagram? Okay, I'll make the shear force diagram, guys. Okay. Now, sir, at the end, at the first end, there is a load W. There is the load W acting downward. There is a load acting downward. So I'm going W downward. I'm going W downward. Absolutely correct now. Okay. Now, then after, sir, there is no loading till the support. So till the support, there is the support reaction upward going W. Absolutely correct. And sir, no loading till the another end. No loading till the another end. Then there is the upward reaction W. Absolutely correct. And no loading till the another end. So no loading till the another end. But at the end, there is the load W acting downward. There is a load W acting downward, guys. Okay. So this is W. This is W. Sir, the shear force at the middle portion is 0. The shear force in the middle portion is 0. So what is the answer? The answer is A, guys. The answer is A. Okay. The answer is A. The answer is A. Okay. Okay. What is the shear force in the overhang part? Sir, the shear force in overhang part is equal to what? Is equal to the W, that is the load. Okay. Okay, next question. Next question. A very, very and important and a good question to discuss. Okay, mark down the answer quickly. So mark down the answer quickly, guys. The bending moment of the cantilever beam at A shown in the figure. So you have to calculate the bending moment at the A. You have to calculate the bending moment at the A. Okay, guys. How can you calculate? How can you calculate, guys? So calculate na. How can you calculate? Anyone in the chat section? So let us make the okay. Let's make the simplification easy. Okay. Now, sir, we have the cantilever beam given. Okay. Okay, let us suppose there is the moment MA at what? MA at the at the fixed support. So I'm writing the moment MA. I'm writing the moment MA. Okay, I'm writing the moment MA. Absolutely correct. So let us suppose, sir. Let us suppose. Okay, okay. I'll keep this as it is. Okay. Now there is the load. Okay, Arvind. Arvind. Okay. So बहुत time के बाद मिले. Zero is the answer. Okay. So 2T load is acting at the B. Okay. Now the moment at A will be, moment at A will be, sir, 2t, it will cause what? It will cause the clockwise moment. So clockwise moment will be taken as positive. 2t acting at what distance? At the 2 meter. Okay. Sir, minus this moment. The moment is 40. Minus this moment 40. The moment at A is 0 simply. The moment at A is, guys, 0. The answer is absolutely correct. A is the answer. Okay. The moment at A is absolutely correct, 0. Next question for you. Next question for you. Okay, next question for you. What is the answer? So the shear force of a cantilever beam of length carrying the UDL, uniformly distributed load, or W per unit length at the free end. So you have to calculate the shear force at the free end. So C is the answer. Where is the C? Arvind says 0 is the answer. Is that correct? Let us see is that correct? Is that correct? Let us see. So the shear force of the cantilever beam subjected to UDL. Okay. So we are making the cantilever beam which is subjected to UDL. So this is cantilever beam subjected to UDL, which has the load intensity small w. Let us suppose small w. Okay, guys. Small w. Load intensity is small w and the length is L. What is the reaction developed at the fixed end? The vertical reaction will be WL. The vertical reaction will be WL. I'm making the shear force diagram. Making the shear force diagram. Sir, we know that. We know that. Okay. The load is what? The load is linear. The load is what? That is linear. Okay. The load is acting linear. That means shear force diagram. नहीं change नहीं है ये वही channel है. That is the shear force diagram will be what? The shear force diagram will be linear. Okay, so here is the shear force of equal to the reaction. That is WL. It is linear, 0 at the other end. 0 at the other end. So A is the answer. A is the answer. Okay. Next question. Next question. Next question. So I have a surprise for you guys. I have the surprise for you guys. Okay, Arvind. I have the surprise for you. I have the surprise for Arvind and Batu. Okay. Okay. So the simply supported beam resting on each support be apart and having equal overhangs on both the sides. Okay, equal overhangs on both the sides. The ratio of B by A for zero bending moment at the midspan. The ratio of B by A. The ratio of B by A. So let us take the beam, sir. There is no loading given. There is no loading given. Remember. So this question is not true. Okay. There is no loading given. Now let us take the loading as the UDL. Now you can calculate by yourself. Okay. You can calculate by yourself. You can calculate by yourself. Okay. So Arvind is saying that B by A is 2. B by A is 2. Okay. B by A is 2. You can calculate this. Okay. By yourself. You can calculate this by yourself. Okay. I'm not wasting the time. I'm not wasting the time. Now, another question, guys. Another question. Okay. Another question. WL by 3. Okay. A simply supported beam carrying two equal loads concentrated W. Okay, at the distance 1 by 3 from either side. Okay. So this is the beam. This is the beam. Okay, we are applying the loads at L by 3 from both the supporters. At L by 3 from both the supporters, it is L by 3. Middle portion will be L by 3. This portion will be L by 3. Now, guys, I'm making the bending moment diagram. How the bending moment diagram will look like? Okay. Okay, sir, the load is concentrated. That means bending moment diagram linear. But in the middle L by 3, it is constant. It is constant. Okay. And at this portion, it is again linear, and the value is L by 4, WL by 3, sorry, and the value is WL by 3. Okay, this ordinate will be WL by 3. Okay, absolutely correct. This will be WL by 3. Okay, so answer is B. Answer is B. Okay, next question. Next question. These are easy questions. Guys, Arvind, these are easy questions. These are very, very easy questions. You can solve in a matter of time. Okay. I think these are around 50 questions. So if you try to solve these quickly, we'll complete 50 questions. Okay. We'll complete 50 questions. Always zero. Okay. So anyone else? Anyone else? We have the shear force and bending moment, bending moment at the free end of the cantilever beam are. So always remember for cantilever, everything happens at the fixed support. Everything happens at the fixed support. That means on the free end, there will be zero shear force, there will be zero bending moment. Okay, there will be zero bending moment. So it is always zero. So the correct answer is D, guys. Okay, Arvind, wait a second. I have a surprise for you. Okay, I have a surprise for you. We'll continue the class then. Wait a second, sorry. Okay, so this is a surprise. We are having scholarship test 25th, 26th, and 27th December. Okay, okay, on our application. The app link is provided in the description. Okay, so you will get 85% scholarship. The syllabus is all technical. Okay, the syllabus is all technical. You'll get 70% scholarship if you able to maintain the 6 to 12 rank. Okay, okay, Arvind, Arvind, will you able to attend the scholarship test? Okay, I want you to attend the scholarship test. Everyone in the class. Okay, you are my okay. You are my previous student, so I want you to attend the scholarship test. 25th, 26th, and 27th December. Okay. Now let us start the class. Let us start the class again. Okay. So okay, this is the another question now. This is the another question. This is the another question. So the bending moment at the free hand A of a cantilever beam of length L with the concentrated load W at the tip. With the concentrated load W at the tip. So, okay, in the last class we have discussed that. Okay, in the last class we have discussed anything for the cantilever beam will be zero. At what? At the free end. Okay, so I am making what? I am making the bending moment diagram. Sir, the load is concentrated load. Okay, the bending moment induced at the free end will be W. Sorry, fixed end will be WL and it will be anti-clockwise. So this will be the diagram. This will be the diagram, guys. This will be the diagram. Okay. And at the free end, it is 0. At the fixed end, it is WL. Okay. Okay. So it is 0. Next. Okay. What is the bending moment diagram? What is the bending moment diagram? Okay. Let's make the bending moment diagram, guys. Okay. This is the beam. That is the symmetrical beam. That means the load reaction will be W here. The load reaction will be W here. Okay. Absolutely correct. Now, let us calculate the moment. Sir, at this support, or at this end, the moment will be zero. Okay, at this end, the moment will be zero. Now, what are the moment induced at what? At the supporters. Sir, there is the load W acting at L distance. So I will stand at this point. I will stand at support. Look towards the right or left. Okay, the easy is to look towards the left. So the bending moment here is WL. Likewise, the same, I'll stand at this. I'll stand at this point, and the diagram, okay, I'll stand at this point and look towards the left. The load is W. Absolutely correct. The load is W, guys. Okay, and acting at L distance, this will be the moment induced. Remember, this will be the clockwise movement, and this will be the anti-clockwise movement. This will be the anti-clockwise movement. Now, when there is concentrated load, sir, for concentrated load, the variation of the what? The variation of bending moment diagram is linear. Is linear, absolutely correct. So the diagram will be linear. So the diagram will be linear. You can make the diagram because I have calculated the moments. So let us make the diagram, guys. Let us make the diagram. Absolutely correct. Okay, let's make the diagram. Now, sir, at the supporters or at the end, sorry, there is a zero moment. And at the supporters, sir, there is an anti-clockwise moment that is WL. And on the other support, there is an anti-clockwise moment that is WL. Okay, I'll join the two. This is the bending moment diagram. This is the bending moment diagram and zero at the end. Okay, okay, so it is the linear. Next question for you. The necessary condition of the equilibrium of bodies, the necessary condition of the equilibrium of the bodies. What is the necessary condition for equilibrium? Okay, all of the above is saying. Arvind is saying all of the above is correct answer. The necessary condition of equilibrium of the body is, in the structural analysis, we are analyzing the body by taking the equilibrium conditions. By taking the equilibrium conditions. That is, we can assume, okay, we can assume summation fx, that is force in the horizontal direction, must be equal to 0. We can assume summation fy, that is force in the y direction, is equal to 0. And we can assume summation of moments around the z direction is 0. Okay, so these are our conditionals. These are our conditionals. Okay, you should remember these conditions. Now, let us say first the algebraic sum of all the horizontal component force must be 0. Okay, so this is correct. The algebraic sum of all the vertical components of force must be 0. The algebraic sum of moment. So these are the points which have been discussed. Next question. Next question. Next question, guys. Okay. The answer is what? B. The answer is B. Okay. This was the first question of our day. This was the first question of our day. Let us suppose this is our cantilever beam. Let us suppose this is our cantilever beam. So on this cantilever beam, I am applying the moment clockwise M at the free end. So I'll make the diagram now. I'll make the bending moment diagram. Sir, when we apply the moment M in the clockwise direction at the free end, there will be induction of the moment M in the anti-clockwise direction. Now I'll make the diagram. Okay. Okay, no shear force in this case. Absolutely correct. Now I make the diagram. Okay, at the fixed support, then I am going MW, sorry, I am going M downward. Okay, and now there is no movement, constant movement till the other end, that is the free end. There is a movement M acting in the upward direction. So I am going up, okay, upward. That is in the clockwise direction. So this will be the BMD, bending moment diagram. That is a rectangle. Okay, the answer is B. Okay, the answer is B. Okay, next question. A very, very important question, guys. Very, very important question for you. So like the session, guys. Please like the session. So answer. I want the answer. Where is Arvind? So first case is that if a beam is simply supported at the two end, okay, guys, is loaded by the point load at the middle of the span. Absolutely correct. The maximum bending moment is M. Okay. if the same load is equally distributed. Now this load W, which was okay, now this load m by 4. Now this load is equally distributed now. Okay, the maximum bending moment, neglecting the weight of the beam will be. Okay, so I'll take the case first. So this is a simply supported beam. This is our simply supported beam. We are applying the load W at the mid span. We are applying the load W at the mid span. Okay, absolutely correct. Now, guys, this will be what? What is the bending moment? Maximum bending moment. The maximum bending moment M will be equal to WL by 4. WL by 4. No tension, sir. Everything clear. Now, this W, guys, this W is uniformly distributed now. That means I'm taking the beam. I'm taking the beam. Simply supported case beam. Absolutely correct. Simply supported beam. Absolutely correct. On this beam, on this beam, I'm applying the load. Okay, I'm applying the load. Sir, this load is what? This load is W, small w. This load is small w intensity. And the total length is L. And the total length is L. Now, we know that the total load is WL. Sir, that is equal to the capital W. That is equal to capital W. So we can calculate the small w as capital W by L. Okay. In this case, the maximum moment is how much? In this case, the moment is m dash is WL square by 4. Sorry, WL square by 8. So small w L square by. Okay, we'll put the W value. That is W by L, capital W by L, multiply by L square by 8. So that is what? That is WL by 8. WL by 8. Now, sir, WL by 8. So I'll write down m dash is equal to what? I'll write down m dash is equal to WL by 4 multiply by 2. Absolutely correct, sir. WL by 4 is m, guys. M by 2 is answer. So your moment will be m by 2. Your moment will be m by 2. A is the answer. Arvind, correct yourself. A is the answer. A is the answer, guys. Okay. Next question. Next question. Next question. Next question, guys. I want the answer now. The load at the free end of a uniformly cantilever beam is increased. Okay. The failure will occur. Where will the failure occur in case of the cantilever beam? Where will the failure occur in case of the cantilever beam? Anyone? Okay, B is the answer. Okay. Let us suppose, guys, at the middle, at the application of load, anywhere in the spawn, the maximum moment fixed end pe hoga. Okay. So wait a second, sir. The load at the free end. The load at the free end. I told you for the cantilever beam, everything happens at what? Happens at the fixed support. Okay, that means, guys, I am increasing the load. I am increasing the load. That means the moment will be induced at the fixed end, and the moment will be how much is the load and multiply by the length. That is the PL. Okay, the failure will occur at what? It will occur at the fixed end. It will occur at the fixed end, guys. Where will it be occur? Sir, it will occur at the fixed end because the maximum moment is induced at the fixed end. Okay, next question. Next question. Next question. Pointers of contraflexure. The point is, guys, why the beam is supported, beam moment is zero, shear force is zero, bending moment changes sign. What will happen at the points of contraflexure? Bending moment changes the sign. Bending moment changes the sign. So what will happen? What will happen, guys? Okay. So these are the pointers. These are the pointers. Okay. Where what? Where the bending moment changes the sign. Okay. The bending moment changes from the clockwise to the anti-clockwise. Okay. So the answer is D, guys. Okay. The answer is D. Next. Easy question is to discuss. Okay. Very, very easy question is to discuss. Equal to 0. Okay. So we have usually the three types of supporters. We have five types of supporters, but usually we take the three types of supporters. Okay. Okay, three types of supporters. Absolutely correct. Okay. So this will be fixed support. This will be fixed support. At the fixed support, there are three reactions. That is the vertical reaction, that is the horizontal reaction, and the moment M. Okay. And we have another support, that is the hinge support. So at the hinge support, there is only vertical reaction and there is horizontal reaction. There is no moment. The moment is zero. Moment is zero. And there is the roller support commonly used. For the roller support, there is only what? Vertical reaction V. There is horizontal reaction 0. And the moment M0. Okay. And the moment M0. So what is equal to the 0? Equal to the 0. B is the answer. Okay. Next. Next. So the number of points of contraflexure in simply supported beam carrying uniformly distributed load is. What are the number of points of contraflexure? So I'm making the beam. I'm making the beam. Okay. Simply supported beam subjected to UDL. UDL. Okay. In case of the UDL, the variation is parabolic. In case of the UDL, the variation is parabolic. Okay. The variation is parabolic. And the maximum bending moment will be at the center. Okay. Sir, no what? No point of contraflexure. So the answer should be 0. Answer should be 0. Next. Okay, everyone. Everyone, come on, guys. I want the answers. I want the answers. So the moment diagram for a cantilever carrying linearly varying load. Now there is the linearly varying load. Remember, okay, from 0, linearly varying load from 0 at the free end and maximum at the fixed will be. Okay, it is a cubic parabola. Arvind is saying that the answer is cubic parabola. Okay, let's see now. Let's see now, guys. Okay, sir, this is the cantilever beam. Okay, the moment diagram I have to perform. Okay, I have to make. Okay, so this is what? This is the loading. This is the loading. Let's suppose the coordinate of this load is W. Sir, the load is what? The load is linearly varying. That is 1 degree varying. Okay, that means shear force diagram will be 2 degree, and the bending moment diagram will be 3 degree. That is parabolic. Okay, parabolic hoga. Absolutely correct. That is cubic parabola. Sorry, that is the cubic parabola. Okay, guys, that is the cubic parabola. Okay, next question. Next question. Next question. So the shape of cable under UDL. The shape of cable under the UDL horizontal load is. Okay. So there are different shapes. It may be contrary, it may be parabolic. Okay. But when we apply the load, the shape of the cable, the shape of the cable, okay, the shape of the cable under the UDL horizontal load will be what? It will be parabolic. Okay. It will be the parabolic. It will be the parabolic. Under the self weight, okay, under the self weight, it will be contrary. Okay. Absolutely correct. Next. Okay. I want everyone answer. I want everyone provide me the answer. Please provide me the answers in the chat section. So I have a surprise for you. We are going to conduct the scholarship test for AJ exams, okay? On our app. What is the shear force? How we can define the shear force, guys? How we can define the shear force? Anyone? Remember, the shear force is defined as the algebraic sum of the what? Algebraic sum of the forces to the transverse section. Okay, to the transverse section. Wait a second. To the transverse section. Wait a second. Okay. Okay. So let us take the beam. Let us take the beam. Sir, this is the beam, simply supported beam. We are applying the loads. We are applying the loads in transverse direction. Okay. Let us suppose this is the loading. Sir, I am cutting the section this. Okay. So this is our section. This our section. Okay. Sir, we know that, okay, there is a different shear force at the different sections. Okay, the variation is linear or it may be straight. There is a different shear force at the different at the different sections. Okay, so now when we cut the section, sir, I have cut it the section. Absolutely correct. So there will be application of the shear stress. This will be the shear stress. That is the transverse forces. Okay, algebraic sum of transverse forces of the section. Okay, that is the shear force. So D is the answer. Next. A cantilever carrying a uniform distributed load, W over it is full support. Its proper at it is free end. Okay. Okay. What is the proper cantilever? That means the free end is under the roller support. Okay. Absolutely correct. Now the bending moment will be zero at the free end. Absolutely correct. And also at what? At so also at where? You have to calculate. You have to calculate, guys. So how can you calculate? Remember, guys. This is the cantilever, proper cantilever. I'm making the proper cantilever. Subjected to UDL. Subjected to UDL. Okay. Subjected to UDL. Let us suppose small w kilonewton per meter is the intensity. Okay. And what, guys? This is the length L. This is the length L. Absolutely correct. And there is the proper end. There is the proper end. Let us suppose there is the reaction R. At the proper end, there is the reaction R. Okay. There is the reaction R. Now, it is free and okay, such that at the level of fixed support. Sir, that means there is what delta, that is deflection at B, and deflection at B, let us suppose this is B, is zero. Okay. Sir, how the deflection can be calculated by the load W? By the UDL. The deflection will be WL power 4 by 80I. That is equal to deflection produced by the load R. Okay, reaction R. When okay, this is ulta cantilever, that means reverse of cantilever. So the deflection caused by the R is how much? Sir, that is equal to RL cube by 3EI. RL cube by 3EI. Absolutely correct. Now the reaction R will be equal to 3 by 8 of WL. Sir, this reaction is equal to 3 by 3 WL by 8. This reaction is 3 WL by 8. Okay. Now let us take the section. Okay, where the moment is. Okay, where the moment is zero. Okay, where the moment is zero. Let us suppose this XX section, which is at the X distance from the proper cantilever, is equal to zero, guys. Okay, is equal to zero. So I'll write down the moment at the X. Now, how can we write down the moment at X? So I'll stand at the X, look towards the right, look towards the right. Sir, there is the reaction 3WL by 8, 3WL by 8 acting at X distance. Sir, minus what? minus there is this load intensity W. The reaction, the moment will be Wx square by 2. Sir, the moment x is 0, mx is 0 because at x section that is 0. Okay. Now you can calculate the L value. You can calculate the x value. Okay. You can calculate the x value. It is 3WL, 3WL by 8 equal to what? Equal to x by 2. Okay, you can calculate now. You can calculate now. So the x value is what? X value is what? It is 6 by 8 of L. 6 by 8 of L. That is 3 by 4 of L. Absolutely, the D is the correct answer. Okay, D is the correct answer. Next. Next, D is the correct answer. Again, a very easy question. Very easy question and a good question to discuss. Are you getting my points, Arvind? Are you getting my points? Okay. Anyone else in the chat section who can provide me the answers? Look, a beam of uniform flexibility. EI is constant for the beam. Okay. What is the value of load W if the magnitude of bending moment at the midspan and at the support of the beam are numerically equal? So you will first calculate the moment at the two locations. Then you will put equal. Okay. Then you will equate the two. You will get the value of W. You will get the value of W. Come on, guys. I want the answers. Want the answers, guys. Okay, 20 kilonewton. Okay. So let us first calculate the moment at one support. At the moment at one support, how can I calculate the moment? Always remember, sir, stay at R. Okay, I will stand at R. I will stand at R. Look towards the right, towards the left. Sir, the left is okay. The left direction is easy. The left direction is easy, guys. Okay. So there is the moment what? Let us suppose the moment at the support is ms. That is equal to what? Sir, that is equal to anti-clockwise movement. It will cause anti-clockwise movement. That is minus 10 multiply by what? Sir, multiply by 2. Multiply by 2. So it is the minus 20 kilonewton meter. Minus 20 kilonewton meter. Absolutely correct. Now movement at the midsection. Movement at the midsection. So movement at the midsection M is equal to, sir, there is the reaction. This will cause clockwise movement. This will cause clockwise movement. That is the R. Okay, what is the reaction? What is the reaction R? What is the reaction? From the symmetry point of view, the reaction R will be, guys, here. The reaction R will be simply the 10 plus W. The reaction R will be 10 plus W. Okay, the reaction R will be 10 plus W because the load is 10, again the 10, the load is W. Okay, it is W by 2. Sorry, it is W by 2. Okay, it is W by 2. Okay, so half of the reaction now. Okay, so the reaction is 10 plus W by 2. The reaction is 10 plus W by 2, and it acts at what? So it acts at 2 meter. The total is 4. This much is 2. It acts at 2 meter. Minus, sir, this will cause anti-clockwise movement. That is the 10 kilonewton acting at how much distance? So the 10 kilonewton acts at what distance? At what, sir? 4 meter. So the moment at M is how much? That is 20 plus W minus what? 40. Sir, this is equal to what? This is equal to moment at the support. That means I will write down 20 plus W minus 40 is equal to minus 20. You can calculate now. You can calculate now. So it is what? How much is the answer? So it is 20 plus 20. That is 40. 20. Okay. 20 plus 20 is 40. Absolutely correct. Okay, wait a second. 20 plus 20 is 40. 20 plus 20 is 40. Okay, 40. What is the problem? What is the problem? Okay, 20 plus 20 is 40 plus W minus 40. Okay, the answer is 0. W is coming to be the 0, but there is no 0 provided in the options. What will happen, guys? Okay, I think I have done the mistake anywhere. I have done the mistake, I think. Okay. So let us recheck this question. Don't worry. We'll recheck this. Don't worry. We'll recheck this. Okay. Mark down the answer for this now. We'll recheck this. Don't worry. Okay. We'll recheck this. Don't worry. What is the answer? The rate of change of bending moment is equal to the shear force. We know that dm by dx. Dm by dx is what? Shear force. The rate of change of shear force is equal to loading. ds by dx is what? Loading W. Both the statements are correct. D is the answer. Okay. D is the answer. Next. You have to calculate the vertical reaction at A. You have to calculate the vertical reaction at A. 10 kilonewtons. Okay. So how can we calculate, guys? Let us suppose there is the reaction, vertical reaction VA. There is a vertical reaction VA, and there is the vertical reaction VB. Okay, upward. Let us suppose. Okay. So by taking summation of fx is equal to 0 or fy is equal to 0, so I can write down the VA plus VB. VA plus VB is 50. Okay, no problem. Now, sir, we have to calculate the vertical reaction at A. So I will take the moment around B is equal to 0 because of the hinge support. Moment is 0. Okay. So I'll write down the moment around B. Sir, there is the vertical reaction VA acting at how much distance? Sir, acting at 4 plus 2 plus 2, that is at 8-meter distance. 8-meter distance will cause the clockwise movement. Okay. And there is the 50 kilonewton load acting at 4-meter distance will cause opposite reaction, that is anti-clockwise movement. Acting at how much distance? Acting at the 4-meter. Acting at the 4-meter. And there is the movement, that is the clockwise movement. Okay, that is the clockwise movement. So I'll write down the moment of 120. That is equal to 0. That is equal to 0. So the vertical reaction VA will be equal to, this is minus 120. Okay, minus 120 plus 200 divided by 8, and that is equal to 10 kilonewton. So the answer is A, guys. The answer is A. Okay, the answer is A. Okay, the answer is A. Next. The answer is A. What is the answer? Guys, this is the cantilever beam subjected to UVL, that is the uniformly varying load. Okay, so the reaction, you have to calculate the reactions at the support, that is the moment and the vertical reaction. Moment and the vertical reaction. Okay, how can you calculate now? How can you calculate now, guys? So you know that, sir, this is total load. This is the total load. Total load is 120 kilonewton. So the upward reaction is how much? The upward reaction will be 120 kilonewton. Okay, absolutely correct. Now we have to calculate the moment. It is kilonewton meter. Okay, you have to calculate the moment now. How can you calculate the moment at the free end? Guys, this is the triangular load. This is the triangular load. Okay, so for the calculation of moment, I need what? Guys, I need the centroidal distance of this load. I need the centroidal distance of this load. Suppose this is the centroidal distance of this load. Okay, okay. Now, how much is the centroidal distance? Sir, that is equal to 3 by 2 from the base. Oh, sorry, that is 2 into 3 by 3 from the base, and that is equal to 2 meter. So the centroidal distance is 2 meter. I can calculate the moment at the fixed end. Is the total load, that is 120 kilonewton acting, multiply by the centroidal distance. That is what? Sorry guys, sorry. It is h by 3. Sorry, it is h by 3. This distance is h by 3. So h by 3 is what? So that is 3 by 3. So h is 1 meter. So h is 1 meter, guys. So I'll calculate h is 1 meter. So the moment will be 120 kilonewton meter. Okay. Okay. From the base it is h by 3. But from other side it will be 2h by 3. From other side it will be 2h by 3 from the vertex. Okay. Arvind, are you getting my point? So it is 2h by 3 from other side. It is h by 3 from base. Okay. So the answer should be 120 and 120. A is the answer. Okay. A is the answer. Next question. Next question. लोड इन किलोन्यूटन होगा ना सर? एब्सोल्युटली करेक्ट. बिल्कुल होगा, बिल्कुल. किलोन्यूटन तो लिखा है ना ऊपर. लोड इज 120 किलोन्यूटन. टोटल रिएक्शन विल बी 120 किलोन्यूटन आल्सो. Okay. The symmetrical frame I, okay, of consisting of two inclined members PQ and Q are connected at Q. Absolutely correct. With rigid joints and hinged at P and R. अरे रिएक्शन क्या होता है? मूवमेंट भी तो रिएक्शन है ना. देखो, मूवमेंट भी तो रिएक्शन है ना. मूवमेंट भी आपका रिएक्शन है. अब यहां से ऑप्शन भी देखो, किलो न्यूटन मीटर. मूवमेंट भी तो रिएक्शन होता है. अब यहाँ पे खाली वर्टिकल रिएक्शन होगा, हॉरिजेंटल तो नहीं होगा. क्यों हॉरिजेंटल कहां से होगा? जब हॉरिजेंटल लोडिंग है ही नहीं, तो वर्टिकल रिएक्शन ही होगा. है समझ? वर्टिकल रिएक्शन ही होगा. चलो, ये आज का लास्ट सेशन था. ठीक है. चलो, आपके लिए क्या है देखो. अब सबके लिए देखो, कल कल के लिए सरप्राइज आप सबके लिए. देखो, कहाँ चला गया? एक सेकंड. तो ये जो स्कॉलरशिप टेस्ट है, कल हमारे ऐप पे होने वाला है. ठीक है, कल हमारे ऐप पे होने वाला है. तो आप सबसे रिक्वेस्ट है कि आप डाउनलोड करोगे ऐप. ठीक है, और ये स्कॉलरशिप टेस्ट है, इसका फायदा उठाओगे. ठीक है जी, स्कॉलरशिप टेस्ट का फायदा उठाओगे. देखो आपको कितना फायदा इसमें मिल रहा है. 85% स्कॉलरशिप मिल रहा है आपको. ठीक है, रैंक 1 से 5 लेके आने में. और इसका जो सिलेबस होगा स्कॉलरशिप टेस्ट का, वो खाली टेक्निकल होगा. वो खाली सिविल टेक्निकल होगा. और स्कॉलरशिप, ठीक है, एंड द स्कॉलरशिप विल बी अवेलेबल फॉर 25th, 26th एंड 27th December. Okay. Okay. So these are the dates of the scholarship test. Okay, guys. So see the offers, guys. Okay. So you will get a batch in, I think, 500. Okay, below 500. I think below 500. Okay. You will get the batch in, okay, less than 500. Guys, you will get the batch in less than 500 rupees. Okay. Timing is all allowed. 25th, 26th, 27th. Okay, it will be available in 3 days. 24 hours. 24 hours. Don't worry. 24 hours a day. Okay. I mean, no timing. 25th, 26th, and 27th. Okay. Okay. And also, okay, this second poster of this scholarship, 85% off. Okay. 85% off on RRB JE batches. also on state batches, okay, also on state AEG batches. So we are discussing their SOM. We are discussing their SOM, okay, strength of material, and then we will start our new subject in in within days. I think in 4 to 5 days we'll start new subject. Okay, we'll start new subject there. Okay, so first you have to perform this. You have to attend the scholarship test. That is on 5th, 6th, and 27th December. Okay. So thank you so much for joining the class. Thank you everyone. Keep sharing, keep okay, liking and keep subscribe our channel. Okay, guys. Okay. So you have to like, share, subscribe our channel. Okay. We'll provide the best content for you. Best content for you. Thank you so much, guys. Thank you so much. Thank you for being with us. Thank you. Thank you. Arvind, and remember the class timing. It is always at 8:30. Okay. It is always at 8:30. So thank you so much. Thank you guys. Thank you so much.